After the collision, both bullet and log will travel in the same direction. So that is why we have to calculate the common velocity, kinetic energy of the system before collision minus kinetic energy of the system after collision. So taking the difference, we will come to know what is the loss. What is power? We have to calculate power. So power can be calculated by the formula work done in a given time. So for this, we need W value. Hello everyone, welcome to session 4 of chapter 6 Work, Energy and Power. This is Swati from Department of Physics, Vidhyaashram University College, the Temple of Excellence, Mysuru. Dear children, till session 3 we have discussed about the theory part of this chapter, work, power and energy, and we have even derived so many expressions which are related to energy and many more. And in this session, we are going to discuss about the numericals which are related to the things which we have discussed in this chapter. And we begin with the first problem, that is a bullet weighing 50 grams hits into a wooden log of mass 2 kg with a velocity of 150 meter per second. If the collision is perfectly inelastic, calculate common velocity after the collisions and the loss of kinetic energy of the system. We are talking about inelastic collision here, where we know that the only momentum is conserved but not the kinetic energy. If there is no conservation of kinetic energy, then we can take the difference between kinetic energy of the system before collision and after collision, and we can find what is the loss of kinetic energy. And the first task we have to calculate is the common velocity after the collisions. So whenever the bullet strikes the wooden log, they move with the common velocity, they both will move with the same velocity. So what is that common velocity? We have to calculate. So for that, let us make use of the given data. So the data given here is a bullet which is weighing of 50 grams. So the mass of the bullet is 50 grams, but the standard unit of weight is, or the mass is kg. So we have to represent this in kg, that is 50 into 10 power minus 3 kg. Or we can write it as 0.05 kg. Next, it is given that the wooden log of mass 2 kg, that is M2 is equal to 2 kg, and with a velocity of 150 meter per second. Here, the bullet weighing 50 grams hits the wooden log of mass 2 kg with the velocity of 150 meter per second, which means U1 is 150 meter per second. Here we are talking about velocity and the unit of velocity is meter per second. If the collision is perfectly inelastic, calculate common velocity after collision. So here we have to calculate common velocity after the collision. So after the collision, both bullet and log will travel in the same direction. So that is why we have to calculate the common velocity. So for that we have to consider momentum before collision is equal to momentum after collision. So how to write the expression for momentum before collision? So general expression for momentum is P is equal to mv. Now before collision, let us write m1 u1 plus, this is the momentum of bullet, and m2 u2, the momentum of wooden log, which is equal to m1 v1 plus m2 v2. But here this expression we can modify this as m1 u1 plus m2 u2, which is equal to m1 plus m2 into v, because after collision we know that they both move with the common velocity, and the common velocity I have considered it as v. So now let us substitute the given values in this expression. So let us substitute. M1 value is 0.05 into u1 is 150 meter per second plus, we do not have the velocity for a wooden log, so u2 value is 0. If m2 is multiplied with u2 for this term, m2 is 2 kg, u2 is 0, and this entire term becomes 0. So which is equal to, now we can write here 0, which is equal to, what is M1? M1 is 0.05 plus M2 is 2 kg into the common velocity V, which we have to calculate. Now 0.05 into 150. So here we will get 0.05 into 150, which is equal to 0.05 plus 2 into V. So let us now simplify this to calculate V. So adding 0.05 with 2, we will get 2.05 into V, which is equal to, we will get 7.5 when you multiply 0.05 with 150, and V is equal to 7.5 divided by 2.05. So V is equal to 7.5 divided by 2.05. Simplifying this, you will get V is equal to 3.695 meter per second. So this is the common velocity of bullet and wooden log after collision. Now we have to calculate the loss of kinetic energy of the system. So loss of kinetic energy can be calculated by taking the difference between kinetic energy before collision is kinetic energy before collision and kinetic energy after collision. What is the general expression for kinetic energy? It is half mv square. So before collision it is half m1 u1 square plus half m2 u2 square minus half m1 v1 square plus half m2 v2 square. This is because we are talking about the system, both the bullet and the wooden log. So kinetic energy of the system before collision, that is sum of kinetic energies of both the objects, minus kinetic energy of the system after collision, that is sum of kinetic energy of two objects after collision. So let us substitute the values what we have in this expression, that is half into the mass of bullet is 0.05 kg into it travel with the velocity of 150 meter per second, that is 150 square, plus we have u2 value is 0 but we have m2 value is 2, 0 minus half m1 v1 value we have already calculated, it is 3.695 the whole square plus half m2 and v2 square is again 3.695 the whole square. Or you can directly substitute the value of m1 here as 0.05 kg and here the m2 value as 2 kg. So let us simplify now. So we will get the answer. Simplifying this, we will get 562.5 plus 0 into anything becomes 0 minus simplifying this, that is half into 0.05 into 3.695 the whole square, we will get the value 0.3345 plus, and simplifying this you will get the value 13.58. So this is the kinetic energy of the system after collision, or we can write it as 562.5 minus 0.3345 minus into plus minus 13.58. So we will get the final value as 548.8 joule. So this is the loss of kinetic energy of the system. Here we can consider kinetic energy of the system before collision minus kinetic energy of the system after collision. So taking the difference, we will come to know what is the loss, and the loss of kinetic energy in the given problem is 548.8 joules. So let us move on to the next problem now. So the next problem is a well 20 meter deep and 4 meter in diameter is full of water. Calculate the work done in pumping the whole of water up to the ground level. It is given that the density of the water is 1000 kg per meter cube. Here the work done has to be calculated. We must understand that the work done is stored in the form of potential energy. So what is the expression for potential energy? It is mgh. So we have to calculate the work done to bring the whole of the water up to the ground level. It is given that the density of the water is 1000 kg per meter cube and it is of diameter, the well is having its diameter 4 meter. When the diameter is 4 meter, the radius can be calculated, that is 2 meter, and it is having a depth of 20 meter. So I can write H is equal to 20 meter. As we all know, potential energy can be calculated as mgh. So we have g term and h, but we don't know what is the value of m. So how to calculate m? By using the expression density. Density is given by mass by volume. So from this we can calculate m value, that can be calculated as rho into v. But is the v value given here? No. So we can calculate the value of V by taking the volume of cylinder, since the well is cylindrical in shape, and it is given by pi r square h. So what's the value of pi? It is 3.14, and r value is known to us, that is 2, and we'll get 2 square into the h value, that is 20. So simplify this, you will get 251.2, and the volume we are calculating, and hence the unit meter cube. Now we know the value of V. Let us substitute in this expression to get the mass. So m is equal to rho V. So what's the value of rho? That is 1000, and V is 251.2 meter cube, and this is nothing but 251.2 into 10 power 3. Since we are calculating mass, it is kg. So m value we have calculated. Now let us calculate the work done. So work done can be calculated as it is stored in the form of potential energy, and hence we can make use of the formula mgh. So what's the value of m? It is 251.2 into 10 power 3, and the value of g is 9.8, and on an average we are calculating what is the work done to bring the water up to the ground level. So on an average value we are considering the value of h is 10. So the answer for the work done in this task is 2.462 into 10 to the power 7. Since we are calculating work done, the unit of work done is joule. So this is the work done in bringing the water up to the ground level. So let us move on to the next problem. Our next problem is a laborer weighing 70 kg climbs 11 step of staircase, each of 0.21 meter height, in 1.4 seconds. Find the power in watt and horsepower we have to calculate, and it is given that the value of g, that is acceleration due to gravity, is 9.8 meter per second square. So in solving any problem, it is very important to understand what are the given data, so that we can make use of the data given, and we can find whatever is to be calculated. So let us now make a note of the data given. So a laborer is weighing 70 kg. He climbs 11 step of staircase, each of 0.21 meter height, and the time he is taking to climb is 1.4 seconds. We have to find power as well as power in watt as well as the power in horsepower. And it is also given the value of g is 9.8 meter per second square. So here we have considered the height of the staircase, that is 0.21 meter each. But what is the number of steps he is climbing? That is 11. So we can find that h is equal to 11 into 0.21. So what's the answer? 11 into 0.21 gives us 2.31 meters. Now we have to calculate work done. Again, work done can be calculated by the formula mgh. What is power? We have to calculate power. So power can be calculated by the formula work done in a given time. So for this we need w value. So how to calculate that? That is m into g into h. So what's the value of m? It is 70 and g is 9.8. H value is 2.31. So the work done is calculated as 1585 joules. Now we have to calculate power with this formula, that is 1585 divided by the given time is 1.4 seconds, and the answer you will get in watt is 1132.14. Power we have calculated, so the unit is watt. Now, the question is to find the power both in watt and horsepower. So, how to calculate this power in horsepowers? So, for that we must have the knowledge of what is 1 horsepower is equivalent to. So, 1 horsepower is equal to 746 watt. That is 1 horsepower is equal to 746 watt. Now, we have calculated the power, we have to represent it in horsepowers. For that, we have to take 1132.14 divided by 746 and the answer we get in horsepowers, that is 1.517 horsepowers. So, this is how you have to calculate power in watts as well as horsepower. So, let us move on to the next problem. Our next problem is a pump on the ground floor of a building can pump up water to fill a tank of volume 30 meter cube in 15 minutes. If the tank is 40 meter above the ground and its efficiency is 30% and the efficiency of the pump is 30%, what is the power consumed by the pump? To pump up the full water, what is the power consumed? We have to calculate. It is given that the density of the water is 1000 kg per meter cube and the acceleration due to gravity is 9.8 meter per second square. As I always say, we have to check the relevant data given to find the solution for the respective problem. So, let us now write the data given in this problem. So, here the volume of the tank is given as 30 meter cube and the time taken by the tank is 15 minutes. So, we have to convert this into seconds, that is 15 into 60. So, what is 15 into 60? We will get 900 seconds. If the tank is 40 meter above the ground, that is H is equal to 40 meter and the efficiency is denoted by the symbol eta is 30%, which is nothing but 0.3. What is the power consumed by the pump? That is, we have to calculate the power consumed by the pump, that is it denoted by power input, we have to calculate. So, to calculate this, we can make use of the formula efficiency, that is always output power divided by input power. So, we have to calculate input power value. We know only the value of efficiency. We need to check what is output power. So, that can be calculated as work done divided by time. So, how the work done is calculated? So, work done is calculated by the formula mgh divided by T. The value of m can be calculated by the formula density into volume, because we know that density is equal to mass divided by volume. From this we can write m is equal to rho into V. So, what is the value of rho? It is 1000 and the volume is 30 meter cube. So, this can be written as 30 into 10 power 3 meter cube. So, now we got the value of m. Let us substitute in the above expression. So, we will get P is equal to 30 into 10 power 3, that is the value of m, and G is 9.8, and what is the value of H? It is 40 divided by the time. Time is nothing but 150 minutes, which is again nothing but 900 seconds. So, simplifying this, you will get 13.067 into 10 power 3. Since we are calculating power, the unit is watt. Now, we got to know the value of output power. Here in this formula, we can substitute the efficiency as 0.3, which is equal to the power calculated is 13.067 into 10 power 3 divided by the power consumed we have to calculate. So, the power consumed from this formula is calculated as 43.53 into 10 power 3 watt. So, this is how you have to make use of the formula of efficiency in calculation of the power consumed by the pump to pump up the whole of water to a tank which is at a 40 meter above the ground level. So, these are the few examples from the chapter Work, Energy and Power. So, you can even try with more interesting problems and enjoy the solutions. So, next session we will come up with another interesting chapter. Please take care all of you and keep learning all of you. See you all in the next session. Thank you.